are watching Darasa Online.
Darasa Online. My name is Mbarako Marabed, a teacher from Changombe Secondary School, teaching advanced mathematics. Today in our session, we are going to revise on the topic of probability. As you know, probability question is no longer an option question. You're supposed to attempt it. Now, join the lesson from now until the end. Hope you'll understand and you'll be able to attempt any question concerning what we are revising here in our lesson. Now, under probability, you're supposed to cover counting, technique for sample space, probability axiom and the theorem, properties of probability. Also supposed to cover conditional probability, probability distribution, but mainly in discrete random variable and the continuous random variable. Lastly, the special probability distribution. These are the subtopics that we'll be revising together in our session. Our lesson for today will focus much on probability distribution, specifically in discrete random variable and a continuous random variable. Why discrete random variable and the continuous random variable? Because this is the specific area in which most of you students, you have problem on how to use the formula to solve a given question. Now let's go together. We have different formula that you need to remember before we go to examples. So formula number one is the formula for finding probability. As you know, probability is always given by number of event over number of sample space, and in which when you add any given probability, you'll ending getting the value of 1. So formula number one is the summation of probability is always equal to 1. So this is our first formula. So this one is used when you are adding any given number of probability, ending that you're supposed to get equal to 1. Also, under discrete random variable, you are supposed to know the formula of finding expectation of variable x, because you'll be given variable x and its probability. So how are you supposed to find its expectation? So these are the formula that are going to be used. I equal to 0 up to n, variable x times its probability. So the formula that you see here on the board is used to find the expectation of discrete random variable. Thereafter, you may be asked to find the expectation now when the variable is squared. No problem. Here, what change here is the value of x. Instead of being x only, so it will be x square, then times probability of x. So these are used to find the expectation of the asked variable. But not only expectation, you may be also asked to find the variance of the discrete random variable. So in which the formula for finding variance of the variable x is given by the expectation of the variable x square minus the square of the mean, as you see displayed on the whiteboard. Thereafter, you may be asked also to find the standard deviation. Standard deviation, we normally use that symbol. Standard deviation is given by the root of variance. The root of variance of the given variable. Because you have the formula for finding variance. Now, standard deviation can simply be obtained by using the formula the square root of the expectation of variable x square minus the square of the mean. When I say the mean, it means the expected mean. Now, this one fall under continuous random variable, the discrete one. Now, what if you are given a question like this one? Find the expectation of a constant a with the given variable x. How do we find the expectation of that variable? My dear student, this a is just a constant number. We normally take it out. So this one becomes a, the summation of the variable x and its probability from I equal to 0 up to n. The same, if you are given the expectation of a constant a and the square of the variable x, it will be a, the summation to n, x square p of x. So it is the same. When you are given a constant, when I say a can be any number. Can be 1, 2, 3. So a is just a constant number. Now, apart from that, you may be asked also to find the variance when given a constant, let's say a variable x. So the formula for variance when you are given a constant become a squared to the bracket of the expectation of the variable x square minus the square of the mean of the variable x. So that are the formula which are normally used when you are dealing with discrete random variable. Because we'll look also on continuous random variable. Let's check again the formula that are used in continuous random variable before looking examples. Under continuous random variable, when you ask to find the expectation of variable x, we normally use this formula. So the expectation of variable x is given by the integral from negative infinity to positive infinity. Then you take the variable that you are given, which is x, you multiply by the given function, then the x. That is when you have to find the expectation of variable x. Also, you may be asked to find, again, the expectation of the variable now squared. What change here is the variable. In the first formula, the variable is only x, but here the variable is x squared. Again, you integrate from negative infinity to positive infinity. Now the function x squared dx. After having the expectation of the variable x and the one with x squared, now you may be able to find the variance. So variance of variable x is given by the expectation of the variable when squared minus the square of the expected mean of the given variable x. So these are the key formula that you are supposed to know them before going to exam. Now let's remind ourselves on how to integrate a given definite integral. So taking an example, we have an integral from 1 to 2 of x plus 3 dx. Hope you remember how to integrate such kind of integral. So 1 to 2 of x dx plus 3 dx from 1 to 2. As you know, when you integrate, this one becomes x squared over 2. Then from 1 to 2 plus 3 x 1 to 2. After that, now the time is for substitution. When you put x here, which is 2, it will be 4 over 2 minus 1 over 2 plus 3 to the bracket of 2 minus 1. Thereafter, it's time now to simplify. So 4 over 2 is 2 minus 1 over 2 plus 2 minus 1 is just 1 times 3 is equal to 3. Use your calculator, simplify 2 minus 1, then plus 3. I have my calculator here. So when you simplify, what will be the final solution? We can go together. So take 2 minus 1 over 2. You'll get 3 over 2. 3 over 2 plus 3. When you add 3, what you'll get? So the final solution is 9 over 2. Now we have seen how to integrate an integral with definite integral or with given limit, like this one, 1 up to 2. Now let's go back to our example that is displayed on the screen. Example number 1. Remember, we are revising on discrete random variable. That is our main focus for our today lesson. It's time now to employ all the formula that you have seen in the beginning of the lesson, one after another. As you see on the screen, a discrete random variable x has probability distribution as shown below. Table that you're given containing variable x 1, 2, 3, 4, 5 with their probability 0.1, 0.3, q, 0.3, and 0.1. So these are just information for a discrete random variable x. Now the question for it, use the table to find the following. First value of q. My dear student, how are you going to find the value of q? Now remember the first part of the lesson. I said there is a formula that is used to give the summation of all probability, which gives equal to 1. Now it's time to use that formula. Now let's go together. Because we are given probability, and the formula summation of probability from I equal to 0. This one give 1. But we are given this probability. I stand for those numbers when x is equal to 1, 2, 3, 4, and 5. Variable x and their respective probability. The variable are given number of 1, 2, 3, 4, and 5. 0, 0.1, 0.3. We are given also q, which is unknown, that we are supposed to find it. 0.3 and 0.1. Now this table or this information will help you to solve this question. Use the table to find the value of q, then expectation of variable x. But you cannot find the expectation of variable x unless you know what is the value of q. So now let's start finding the value of q. To obtain the value of q, because Q is falling under the column of probability. You need to remember the formula for summation of probability, which is always equal to 1. Now, writing the formula, summation of probability, this one is equal to 1. We are given the probability of 0.1 plus 0.3 plus Q plus 0.3 plus 0.1, then this one is supposed to give 1. Now, when you add 0.1 and 0.3, you get 0.4 plus Q. Also 0.3 plus 0.1, you get 0.4, supposed to give 1. 0.4 and 0.4 is 0.8 plus Q is equal to 1. Therefore, Q is equal to 1 minus 0.8, which is 0.2. Redrawing again the table. So the value of Q is replaced by 0.2. Now let's check the next part of the question. Find out the expectation of variable x. How do we find the expectation of variable x? You need to recall the formula for finding expectation of variable x. The expectation of variable x is given by the formula up to n of variable x and their probability. So this is the formula. It needs a column of product between variable x and its corresponding probability. So you go and add a column for x and the probability of that variable, meaning that we are going to multiply one after another. So 1 times 0.1, this gives 0.1. 2 times 0.3 gives 0.6. 3 times 0.2 gives 0.6. 4 times 0.3 gives 1.2. And lastly, 5 times 0.1 is 0.5. Then you can add the summation symbol. Under the probability column, the summation will give you 1. You can use a calculator to prove and see you'll get equal to 1. Now let's add together 0.1, 0.6 up to 0.5. What will be our final summation? Now 0.1 plus 0.6 plus 0.6 plus 1.2 plus 0.5. This one equal to 3. So in our table, the summation for the product between the variable x and its probability give us equal to 3. Now, what are you going to write under the formula of the expectation of variable x? So it's just copying 0.1 plus 0.6 plus 0.6 plus 1.2 plus 0.5. Because you have the summation, then just write here equal to 3. That is the expectation of variable x. Thereafter, we have a question on how to find the variance of variable x. Again, recall the formula of finding variance of variable x. So what you need is just recalling the formula for finding variance, which is given by the expectation of the variable x squared minus the square of the mean, or the square of the expected value of variable x. So this is the formula for finding variance. Now, what are the needs of this formula? We need a column that will help us to find the expectation of variable when it is squared. Remember, our variable here is x. But how do we find the expectation of this random variable x when it is squared? The formula is summation from I0 up to n of the variable x square times its probability. Okay, now we need a column that will give us the square of variable x and their probability. So we're adding here a column for variable x square and their probability. Thereafter, use your calculator to fill that part of the column. Now, as you know, because variable here is square, so it's 1 square times 0.1, this will give us 0.1. 2, when you square, you get 4 times 0.3, you get 1.2. When you take 3 square times 0.2, 3 square is equal to 9, times 0.2, you get 1.8. So you write here 1.8. Again, so when you take 4 square, you get 16. Then you multiply by its probability, which is 0.3. You get 4.8. And lastly, you take 5 square, you'll get 25. Times 0.1, you'll get 2.4. 2.5. Now let's add together. Plug in your calculator. 0.1 plus 1.2 plus 1.8 plus 4.8 plus 2.5. Then the total is 10.4. After obtaining that value of the summation when the variable x is squared and its probability of 10.4, now go back to the formula of variance and then substitute the value. Variance of variable x is given by the expectation of the variable x when it is squared minus the square of the expectation mean square. Now we have the column which gives us 10.4 minus 3, then square. So it's 10.4 minus 9. Again, use your calculator, find the difference. Minus 9, we get equal to 1.4. So that is the variance of the discrete random variable x. But lastly, we ask the question to find the standard deviation. How do we find the standard deviation? Standard deviation is given by the square root of the variance. So finding square root of variance of the variable x will give you the standard deviation of the variable x. But we have it over here, which is 1.4. Again, use your calculator, find the square root of 1.4, which is 1.183215. But here it depends. If you ask to write the answer in number of decimal places or significant figure, my dear student, that one is also a question that might come in your exam. So if it is in 4 decimal places, you'll ending by writing 1.1832. So be careful with such kind of question. After that, now let's tune to continuous random variable x. Again, my dear student, because you have all the formula, now it's time to practice on how to use them. If we are given a question of a PDF function, like the one that you see here on the screen, this one is not a step function, like the one that when you are in Form 3. This one is called the probability density function. Now, under this kind of question, you may be also to find the expectation of variable x and the expectation of the square of the variable x. But how do we do such kind of question? So let's go together until the end of the session, my dear student. We are given a function x with the limit from 0 less than x less than or equal to 1. Also, we are given another function, f of x equal to x 2 minus x. The interval is 1 less than x less than or equal to 2. And the third function is f of x equal to 0, which we normally neglect when you are doing calculation. Now, let's recall the formula. We are looking for the expectation of variable x. The formula is the integral from negative infinity to positive infinity. X, the function of f of x, then the x. Remember, this x, it is in the formula. But you are given also a function that is f of x equal to x. Now, this limit from negative infinity to positive infinity are the one that we are given here, from 0 to 1 and from 1 up to 2. When you say negative infinity to positive infinity, it means you may include negative number and a positive number. But for our question, we don't have negative number. We have number starting from 0 up to 2 only. Now, let's substitute our function in the formula, but without using the negative infinity and positive infinity. We are using the limit that we are given. So number 1 is the integral from 0 to 1. Of which function now? Of the function x. So the function is x. But you have another x that is from the formula. X, then dx. We plus the second function, which is x bracket 2 minus x. If you simplify the function before using the integral sign, the function become 2x minus x squared. So we are going to use this one in our substitution. Now we plus the integral from 1 to 2 of our function 2x minus x squared. But this is the function. We multiply by x that is found in the formula, then dx. Now, when you simplify the integral, you'll be having from 0 to 1, then x squared dx plus 1 to 2. Now, opening the bracket, it will be 2x squared because of this x, then minus x to power of 3 dx. Thereafter, integrate. You'll be having x cubed over 3 from 0 to 1 plus. This one is just a constant number. You can take it out. 2, then integrate x squared separately. You will get x power 3 over 3 from 1 to 0. This one is also a function, that of x power 3. It will be minus x power 4 over 4 from 1 to 2. Then from there, use your calculator, simplify. So if you substitute the value that you're given, in the first part, you'll be having 1 over 3 minus 0 over 3, which is equal to 0. Then plus 2. Here we have x power 3, but we have 2 over here. So it will be 2 power 3 is 8 over 3 minus 1 over 3. And the last one is minus. When you take 2 power 4 is 16 over 4 minus 1 power 4 is 1 over 4. Then after that part, take your calculator and simplify. So if you simplify, you will get the following. So 1 over 3 plus 2 to the bracket of 80 over 3 minus 1 over 3, get 5. Now 5 minus 4 minus 1 over 4. Then again, continue using your calculator. 4 minus 1 over 4. The final solution is 5 over 4, in which when you write into decimal, it will be 1.25. So you may decide to leave your answer in fraction form or in decimal number like that one, 1.25. That one is how to find the expectation of variable x under continuous random variable x. Now let's check the second one. We are also to find the expectation of variable x when it is squared. Now what are we supposed to do, my dear student? Again, remember the formula and then look the needs of the formula. Thereafter, simplify. Okay. Now the expectation of variable x squared as per formula is from negative infinity to positive infinity of x squared, then function of x, then dx. That is our formula. But we are given function x and x bracket 2 minus x. So the integral will be from 0 to 1. X squared. Now we are multiplying with our fixed function, which is x, dx. Then we plus from 1 to 2. X squared, that is from the formula, we multiply with our second function, which is 2x minus x squared dx. Thereafter, simplify first. From 0 to 1, here we are having x power 3 dx plus from 1 to 2. When we open, we'll be having 2x power 3 minus x power 4 dx. Thereafter, keep on simplifying. Now, if we simplify more, it will be from 0 to 1, x power 3 dx. Now, open up plus 1 to 2 of 2x power 3 minus the integral of x power 4 from 1 to 2 dx. Thereafter, let's integrate. So, if we integrate the first part, it will give you x power 4 over 4 from 0 to 1 plus, because this one is a constant number, take it out. So it is 2 to the bracket of, when you integrate x power 3, here there is dx, so it will be x power 4 over 4, again from 1 to 2. Lastly, it will be minus x power 5 over 5 from 1 to 2. Now it's time to do substitution of the limit. So it is from 1, it will be 1 over 4 minus 0 plus 2. When you take 2, power 4 is 16. So it is 16 over 4 minus 1 over 4. Minus the last one. Our value is 2. So 2 power 5 is 32 over 5 minus 1 over 5. Simplify, be having 1 over 4 plus 16 over 4 is 4. So we have 2. So when you take 4 minus 1 over 4, you get 15 over 4. Then minus again, because the denominator is the same as writing 31 over 5. From that point, use your calculator to finalize. So take 1 over 4 plus 2 times 15 is 30. So it's 30 over 4. Then minus 31 over 5. The answer here is 31 over 20. If you decide to leave your answer in decimal, again, use your calculator, take 31 divided by 20. So you'll get 1.55 as the expectation when the variable x is squared. So that is how to find the expectation of variable x when it is squared. But also you may be asked the question, find the variance of variable x. Not only variance, you may be asked to find also standard deviation. How do you find the variance in standard deviation? My dear student, it's very easy. Just recall the formula for finding variance. As you remember, variance is given by the difference between variance of variable x is given by the expectation of the variable when it is squared minus the square of the expectation of the variable x, in which we have all of them. So what you're supposed to do here, just recall back the value of expectation when the variable is x squared, and also the one that is only expectation of x. Do substitution and then write your conclusion. After obtaining the variance, how do you find the standard deviation, my dear student? Standard deviation is given by the root of variance of variable x. Because here you'll be having the value of the variance. Now just take this value that will be here and you plug it, then use your calculator to finalize your solution. Up to that point, you'll be able to answer any kind of question concerning continuous random variable like that one. Also, you may be given a question that is in the form of a linear function. The continuous random variable x has probability density function f of x given by f of x 1 over 8x for the limit from 1 less than or equal to x less than or equal to 3. And also asked to find what is the expectation mean of the variable x. And also what is the expectation when the variable x is squared. Find the standard deviation. My dear student, this question is very easy. Now let's go and check for it. So solution for that question is just recall the formula for finding standard deviation, variance, expectation, and then look at the needs of what are the needs of the formula. Now for such kind of function, we are given only one function, which is f of x equal to 1 over 80x, with the limit 1 less than or equal to x less than or equal to 3. And we asked also to find the expectation of variable x. But we have the formula. The formula is the integration from the given limit, let's say from 1 up to 3, of the function. But the formula contains x. So we have x. This x is from the formula. Now we are multiplying with our function that we are given. Multiply by 1 over 80 x dx. Now upon simplifying, because 1 over 8 is a constant number, take it out of the integral. So 1 over 8, 1 to 3. This one becomes x square dx. What next from there? Now we are going to integrate. So we'll be having 1 over 8 to the bracket of x power 3 over 3 from 1 to 3. Time to substitute the value. So we have 1 over 8. Our value here is 3 and 1. So when we substitute 3, it will be 3 to power of 3 over 3 minus 1 over 3. From there, simplify and see what will be the final solution. This one is the same as writing 9 times 3 divided by 3 minus 1 over 3. So 3 and 3 will cancel. So you have 1 over 8. 9 minus 1 over 3. Because you have calculator, use your calculator to simplify that part. So 1 over 8 bracket 9 minus 1 over 3. So you will ending having 13 over 12. If you simplify and leave your answer in decimal, 13 over 12 is the same as writing 1.08333. So this is the expectation of variable x of our given function f of x equal to 1 over 80x. My dear student, we asked also to find the expectation of variable x when it is squared. How are we supposed to do that one? Again, you recall the formula. If you recall the formula for finding expectation when the variable is squared, but using the same limit from 1 up to 3 inclusive. So the expectation of the variable when it is squared, it will be the integral from 1 to 3. Now, x squared, this is from the formula. But our function is 1 over 80x, then d of x. Thereafter is just simplification. The integral from 1 to 3, here is x power 3 over 80 to dx. So 1 over 8 again out, 1 to 3, the integral of x power 3. When we integrate, we'll be having 1 over 8 x power 4 over 4 from 1 to 3. 1 over 8. So it's 3 power 4 over 4 minus 1 over 4. When we simplify, you'll be able to find the value of when the expectation of variable x squared. So 3 power 4 is 81. So 1 over 8, 81 over 4 minus 1 over 4. So 1 over 8, it's 80 over 4. When you simplify, you get 1 over 8 times 80 over 4 is 20. So we multiply by 20. We will get 5 over 2. So 5 over 2, when you simplify more, you will get 2.5. And that is the value of expectation when the variable is squared. Now lastly, find the standard deviation. When finding standard deviation, you need to recall the formula, which is given by the root of variance of x. But also remember the form finding variance, which is given by the square root of the expectation of variable x square minus the mean of the variable x square. We have all the value. Nice time to substitute them and then simplify. So here it is 2.5 minus. We take 1.08333 square. So use your calculator again. 2.5 minus 1.0833 square. The value here of standard deviation is 1.15169. And that will be the final solution of our question like that one. My dear student, it's time now to go for break. When I'll be back, I'll be answering questions that you have sent them through messages.
You are watching Darasa Online.
I'm back from break, my dear student. As I said before going to break, I'll be receiving messages through the number that is displaying on your screen. And I have a lot of messages, but due to time, I'll pick few of them and try to respond. Message number 1 is from Mr. Innocent, Zunzuri Secondary School, Shinyanga Vijijini. Thank you for an amazing presentation. But I need help. If I given a question that read, if x is the number of heads obtained when 2 coins are tossed once, how am I supposed to draw a table to represent the discrete random variable h? My dear student, this question is very easy, Mr. Innocent. So let's go together until the end of the session. Hope you'll be able to prepare the table and answer any question using your table that you have drawn. And this will be helpful even for the other students that are having the same problem like yours. Thank you for the good question. And this is how you're supposed to do, Mr. Innocent.
You are watching Darasa Online.
You said in your question, you have 2 coins. 2 coin. But in coin, we have only 2 outcomes. If you remember, we have H outcome and the tail outcome, where H stands for heads and T stands for tail. But how do we find the sample space of such kind of an experiment? Because remember, here we are doing an experiment using two coins. Now you need to use tree diagram. A tree diagram is a very easy method to show number of elements. So we'll be having head and tail in the first coin. Also, we'll be having the second coin having tail and the H and tail. Here also head and the tail. After that, you need to write a set containing number of outcome or number of element. So our sample space element will be HH, HT, then TH, TT. So when you count them, you'll see that the number of sample space is equal to 4. Why 4 and not 8? Because HH is taken to be one outcome and not H as 1, 2, 3, 4, 5, 6, 7, 8. So each group is taken to be one outcome, my dear student. Thereafter, because Mr. Innocent is asking how we're supposed to draw a table to display the distribution of the variable h or x as asked in the question. From probability of event, we have number of event over number of sample space. Remember, our event here is the number of heads, which Mr. Innocent denoted by using variable x. If you go back to your sample space, you'll see that there is an outcome that does not contain any h. Okay, now in your head it's clicked that there is a place, it means no head, it means 0. So now you go and draw a table that will contain x and their probability x. Remember, x is instead of using h. So we have seen that we found a place that we don't have any outcome h, so we put 0. But again, if you go back to your sample space, you find there is a place that we have only one h. So I write here 1, and another place will be having 2. Okay. After preparing such kind of table, now it's time to fill. When you don't have h, what is the probability? It means look the outcome which does not contain any h. We have only 1. So it is 1 over 4. So it is 1 over 4. So we write here 1 over 4. Again, when one containing h, we have h, which is 2. So it will be 2 over 4, which is 1 over 2. So 1 over 2. And lastly, where do we have 2h? We have only one outcome, which is this one. So it is 1 over 4. So right there, 1 over 4. Mr. Innocent, that is how you're supposed to prepare your table. Maybe from your table, you may be asked another question. Find the expectation of variable x, the expectation of variable x square, and also find the variance. And lastly, maybe you have to find the standard deviation. Standard deviation of variable x. Hope you remember. It was starting till now. We have gone and through different examples on how to find expectation of variable x, expectation of variable x when it is squared, and the variance. So Mr. Innocent, this now I leave it as a question to you and the other student. But not only that, I prepared a question again to you that you're supposed to take them for more practice. My dear student, don't miss the next lesson.